Hello, everybody. My name is Amir Tabdili. I'm with UnisonIP Consulting, and I'm going to talk about yet another IPv6 presentation. So there were 1,800 emails about IPv6, and I know there's been hundreds of presentations lately. So you're probably thinking, okay, what is this? What makes this one special? So this is not a best practice presentation. What I'm trying to do is that there might be some of you that are just about to get started, and you probably have a network that you're trying to get your thoughts around it. How are you going to get started? This might be something that will give you more data points. Also, you might be somebody that is in the middle of this process. And once you know where everybody else is, and because I've seen in the projects that I do, and I do a lot of projects internationally, where a lot of people are sometimes ahead of the curve in IPv6 deployment. What you see is that a lot of people actually have plans, and what they're trying to do is to verify that against other people's plans. So the typical service provider's dilemma is this. A lot of service providers have more than one network that they have to deal with. So they might have an internet network. They might have a network that is layer 3 VPN based maybe on MPLS for their enterprise customers. And they will have a subscriber network that will have connectivity to both of those. And these networks are multi-vendor, and what makes these a little more complicated is the fact that there is usually interdependency across these networks when you want to do end-to-end IPv6 deployment. So for example, you might have a subscriber that originates on a BRAS, a LAC device. It gets terminated on an LNS, and then from there it needs to get into an MPLS network. So the end-to-end traffic goes through a subscriber network based on one vendor to an MPLS VPN network and eventually to the corporate network. And if you wanted to be able to offer this as an end-to-end service to somebody, you need to think about all the pieces. So I'm going to cover all this specific service provider. Actually, what we did was the design work for the IPv6 deployment and the migration planning for all these three pieces: the subscriber network, the public internet, and an MPLS VPN. A few small assumptions and backgrounds about the project. The first step is dual stack, as a lot of you probably know. And it's only the first step. So as soon as you start talking about the dual stack deployment, people will start asking you what's next. And as a lot of you probably know, there's a lot of different ways to go about the next step. So something like a carrier-grade NAT is definitely part of the puzzle as far as a lot of the people that I've talked to. And so a lot of our designs actually had to keep that in mind. Very early on, we made a decision that the only things we were going to adopt for IPv6 were things that were externally visible. So a lot of you might not decide to do that. A lot of you might think that we're going to do, there might be something that comes from government where all your systems have to be IPv6 capable. We only did what was visible for the end customer. So for example, for management of devices, we want to be able to get the IPv6 information through the specific MIPS, but the actual infrastructure for the network management could stay on IPv4. Same thing with things like Telnet and SSH. So those things, we left them on IPv4. As far as possible, it had to be transparent to the existing customers. So that's kind of obvious. And sometimes this is not as easy as it sounds as we got into it, and I'll talk about that. And a little bit about what kind of transport scheme we had. For the public, the internet network, IPv4 natively was being used. And for the MPLS network, it was based on MPLS. I mean, for the layer 3 VPN network, it was based on MPLS. The products that were deployed in the network were primarily Juniper and Cisco. On the subscriber side, the LAC and LNS devices were the old Junos E-based Unisphere devices of Juniper, which are the ERX and the E320. Then we had Juniper T and M series on the MPLS VPN as PNPE, as well as Cisco routers. And there were two actually separate VPN networks that we had to connect through inter-provider option C for VPNs, and that was part of the IPv6 design as well. And then we also had Cisco CRSs as internet routers as well. And there were also Alcatel devices that were transparent to IPv6 because they were providing VPLS for the underlying metro transport. So the first network I'm going to talk about is the residential piece of this. And there are actually three models. I mean, the two of them where majority of the subscribers used one of these two models. So one of them is a simple routed mode where you have a PPP session from the CPE terminating on the LAC, and then based on the authentication result, it can be handled by the service provider itself, or it can be handed to another ISP. Very vanilla, nothing fancy about that. Or you could actually have an L2TP backhaul where the LAC has an L2TP session to an LNS. And from there, the LNS could be owned by the service provider, or it could be owned by a third party. And from there, it will exit, most often to a MPLS VPN network, where we will talk about separately, and to a corporate network. There was also a third case, which had to do with customers which were using a bridged mode access. And for that, it was actually a very small number of the subscribers in this case that used that. But we actually made design changes, and I want to talk about the profiles. I'll mention that. So let's say you have a PPP-based network for your subscriber network, and you want to move to IPv6. The first question that gets raised is, what model of PPP are you going to use? Are you going to have a dual stack or a dual session? Basically, are you going to have one PPP session with IPv4 and IPv6 riding on top of it, like the one on the left? Or are you going to have two separate PPP sessions? And I'm going to say scaling a lot in this presentation. And due to scaling reasons and many other implementation reasons, the one on the right was never even an option for us. So from the very beginning, we knew that we have to go with one single PPP session. And also involved network management, tools, what customer was comfortable with. So what we have actually was one authentication unified for V4 and V6. The one on the right actually has some interesting applications for IPv6 LNS, for example, but most of the people I've talked to when they have a PPP network are considering the model on the left, which is the one single PPP session. So how do you get started? And that might be actually the most difficult part of this project is, when somebody has nothing in place, how do you get started? Service offering is, probably the most important part for anything you're going to roll out, and for IPv6 is not any different. We spent a lot of time trying to figure out what was offered in IPv4. And I know a lot of you guys probably here have documentation about every service you offer, but some of you probably have stuff that is 5, 10 years old. And that was the case with this customer. And so the first thing we had to do was to go through all the configuration and the documentations and trying to figure out what it is that actually they offer in IPv4. Then the next thing is, do any of these things actually make sense to move forward to IPv6? There are actually many IPv4 things that, and I'll have one example at the end, it doesn't really make sense to carry to IPv4, or it wouldn't be feasible due to scaling reasons. So I'll mention the example is, for example, for IPv4, on the subscriber networks, there's a service called fixed IP, where you get the same IP address regardless of where you log in from. And to do that, the providers actually leak /32s through throughout the whole subscriber network. Well, due to scaling reasons, because it's scaling usually different for IPv6 than IPv4, that's really not feasible for leaking all the /128s throughout the network. So that one thing that's right there, for example, we know you have to do something different. Everything is influenced by scaling. And as you go about doing IPv6, a lot of you have probably run into this. It's very early on that you have to figure out what are the limits of your device, what the limits are for your devices, because as soon as you get into it, it really quickly affects your design decisions. You might have to buy new hardware, you might have to upgrade your software, and you might need new guidelines to what's offered. If you want, I can talk about some of the places where I saw the scaling, and I have a slide on that at the end. And then there's smaller things like licenses. Some devices, like for example, the Junos eBase Juniper routers needed an IPv6 license. So on the subscriber side, what were the first things that we had to do? Interfaces, obviously. You can start from numbering, coming up with a way and scheme for addresses on actual interfaces on the LAN and LNS devices. There are many choices. You got a /126, /127, /64s, and there are many opinions. I mean, I have talked to many people, and there was a presentation from an old NANOG where /64s were actually said to be very wasteful, even for IPv6. What we did pick is /64s, and so we were wasteful. But it was much easier for somebody who doesn't have much expertise in IPv6 to deal with simpler addressing, because we just picked .1 and .2 as the 2 sides of the interface, and that was it. Maybe not the most efficient way of doing things, but that's the way we did it. As far as the IGP, ISIS was a protocol, and we just altered ISIS to carry IPv6 routes. For BGP, we have 2 options. We could have native IPv6 endpoints, right? Or you could actually have your existing IPv4 BGP sessions carrying IPv6 and NRI. And so this is a question of how much isolation you want between services as far as control plane versus what your scaling needs are. And we wanted to keep things as separate as possible, even though we shared IGP because it was easier. When it came to BGP, we always kept things separate. I mean, since then I've done another project in Europe where we even, since we started from OSPF, and OSPF doesn't support v6 natively, and you have to do it to OSPF v3, we decided to have 2 separate IGPs. But if you're starting from ISIS, a lot of times it makes sense just to be a little lazier and just configure ISIS to carry both. So anyways, we picked the least painful option, which was to have ISIS carry both protocols and BGP, native BGP endpoints. And then you also have this idea of all your routing, you have a lot of routing policies in place, and all of those have to be converted. So you have to have, if you're sending a default route, for example, to somebody, you have to convert that for v6. The most difficult part of the subscriber network design is actually how you're going to assign IP addresses to your customer. And this is going to be different from provider to provider. So this diagram basically tells you that there are different parts to this problem. And for IPv4, usually as soon as the user authenticates, they get an address from the radius server. And this is the same idea from v6. And what the difference is that for v6, and you can actually get up to 3 addresses. So you always get a linked local address, and then you also could get an address coming from the ICMP v6 neighbor discovery process for the WAN link. And then there will be a third one, which is new to IPv6 or unique to IPv6, which is the prefix delegation concept, where you actually assign an IPv6 to the CPE, and the CPE then has a chance to assign that to its own network sitting behind it. So if you look at this diagram, then the orange side is basically what happens behind the CPE. This is actually it took a lot of time, because what happens is, depending on how you decide to configure this, and this is very implementation dependent, this is where you run into a lot of your scaling issues, because there's a big difference between having each subscriber burning 2 addresses versus 3 addresses. And also the way you configure the local, if you're doing local pools on the VRAS device, the way you configure them, these are just implementation details, will affect the scaling of the device. And there's the IPv4 and IPv6 have different scaling limits. So just because you can have 10,000 IPv4 customers doesn't necessarily mean you can have 10,000 IPv6 customers or dual stack customers. So when you have a dynamic PPPoE stack like we did, where the actual subscriber interfaces, the VLANs or the ATM sub-interfaces, that actually don't need any change when you go to IPv6. The profile is dynamic, and it gets assigned to the user as soon as they get authenticated. So all the changes for IPv6 for individual DSL user in our case, all the changes for that specific user was contained in a profile, in a user profile. So a user profile that currently has IPv4, certain IPv4 information has to be changed to have now certain IPv6 specific information. These new information are listed there. You need to have an IPv6 loopback, neighbor discovery if you want it to be turned on. Usually providers have an IPv4 policy attached to a DSL customer, so we need an IPv6 policy for security checks and things like that. This is a specific case. We had RPF check for IPv4 customers, so we do the same thing for IPv6. And one of the things that actually was different in our case, and this is something that we actually changed design a bunch of time, is that we had to keep in mind and incorporate into our design the fact that in the future, carrier-grade NAT or CGN would be something that will happen in the network. Even though the exact details were not known, we wanted to have the capability to, based on the authentication results, move a customer from one virtual routing domain to another one so that can be routed to a CGN box. And that actually affected the way we configure the profiles and the AA profiles on the LAC and on the BRAS. So there's a lot of details on, we had to test all of these and see how they actually behaved. And at the end, we came up with basically kind of a hack kludge to have a way to move a customer based on the authentication results from one virtual router to another one so that they can have a different routing domain. DNS servers, just a quick mention, because this was another thing that the behavior wasn't clear till we actually tested it. So how many DNS servers for IPv6 you want to send to a customer? And the problem was that there were many places you can configure this and on ERX. And so, you know, there are 3 places here listed. We picked the same place that we configure IPv4, which is AAA IPv6-DNS by through that command. And then what the design we came up with was that you always get 2 DNS servers, and then if you want to override that, you could do that by configuring it under DHCPv6 local server configuration. So basically DHCPv6 LS is where you do your DHCP prefix delegation, and right under that you can also configure the DNS servers. A quick mention, we had to add accounting support. So everything that you have for IPv4, including counting, needs to be updated for IPv6 counters. The customer already used PPP counters. So since we're using one PPP session for IPv4 and IPv6, the PPP counters already captured whatever they needed. But there was also IPv6 specific counters that we included in our design. And then there was an LNS piece. And a lot of the designs that went into the LAC are also common to the LNS. So we could say that LNS actually is a superset because it has many other things in it that LAC doesn't. So for example, there's actually specific VRF configuration on LNS that connects to the MPLS VPN, including the fact that the routing connections on the LNS to the MPLS VPN network is going to be based on what I'm going to talk about next, which is a 6VPE. So it's based on MPLS. So we talked about subscriber network, and the subscriber network touches from one end through LNS, it touches the MPLS VPN network. From one end, it goes to the internet, which we'll talk about at the end. So MPLS VPN network is basically obviously used for enterprise customer access, and it's a private network. But still, it was part of the scope to have that IPv6 enabled. Since MPLS is already used for IPv4, moving to IPv6 for MPLS VPN network is actually quite simple. The model that is used is called 6VPE, which basically uses a label the same way that IPv4 uses to tunnel IPv6 through the network. What's good about it is that you use the same MPLS LSPs, and the goal is to actually have everything that you have for v4, including the filters and the counters and all the QoS configurations of v4, to have that all work for v6 as well. At least that was the goal. I mean, we actually ran into some implementation issues where not everything was supported, but the concepts are very similar. So all the PE routers that were part of the scope of this project were Junos-based, and in Junos you have IPv6 tunneling, which is a command that you turn on under MPLS stanza. And what that does is that it enables a router to resolve the IPv6 next hops. And then the only other thing you really have to do is turn on IPv6 address family on the BGP sessions. The hardest part of this was not actually figuring out what we were going to do, it was actually the migration planning, so that you turn on the new address families without bringing out all the sessions at the same time. The other thing is that this network also had interoperability testing with the Cisco devices sitting on a separate layer 3 VPN network through option C, inter-provider VPNs, and to support IPv6 across the 2 vendors. That's on the core side. So on the core side, it's very simple. We have MPLS, and you have new address family for VPN v6, and you have this IPv6 tunneling command that enables you to resolve your next hops. On the customer-facing side, there are new IGPs that face the either BGP or static or an IGP that faces a customer. So this is basically a routing on the PE/CE. So this is earlier when I mentioned that you have to first go through your IPv4 configurations and make sure you understand what's there. So for example, the customer told us that we do OSPF peering with our VPN customers. And as we went through and discovered, the configurations were there, but the sessions were not even up. So that's when you realize, well, there's no point of doing OSPF v3 since nobody really even uses OSPF in this case. eBGP, again, you can have eBGP. We decided to go with native eBGP peering towards the customers. Static is very simple configuration, both on Cisco and Juniper. It follows the same idea as IPv4 static routes. And the only new thing really that conceptually was RIP-NG, and the customers were running RIP, which are not that many. We had to test and certify RIP-NG to be used as a PE2C protocol. There is extensive QoS in this network, and we had to update all of that for IPv6. So a lot of time people, when they're talking about IPv6, they say, okay, we'll just turn on the protocols and that's it. And well, it would break things if you really don't have QoS and security pieces in place from the beginning. And you cannot really go to your customers and give that as a service and get your marketing behind it if you really don't have all the pieces in place. And so QoS was a very important part of it, especially since we ran into some hardware restrictions. So in the core, we didn't have to change anything because everything got mapped to the MPLS EXP bits, as long as we decided to keep the QoS consistent between IPv4 and IPv6. So meaning that in an IPv4 voice packet, EF packet, and IPv6 one will have the same behavior. So all we had to do was to define new code point alias mappings on the edge, and in the core we use the same QoS configuration we had. On the edge, on the other hand, we had to have new classifiers for IPv6, both VA classifications and MF classifications. And this is where we actually ran into a lot of problems in the forwarding path, meaning there were older hardware that didn't necessarily support certain filter configurations with multiple classifications in them. And this is just, it happens. When you're doing IPv6, you're going to realize that certain things you thought should just work, will not work. And we saw a lot of those when it came to QoS for IPv6. And it wasn't that it wasn't available, it just wasn't available in the hardware that we were using. Router security, so for a 6VPE case, the core obviously is riding on top of the IPv4 control plane. We're not changing anything, so we didn't have to define any new IPv4 filters on the core side, but there were actually per customer VRF loopbacks. And these each have their own filter attached to them. So this is all actually really the same piece, right? I mean, we are protecting a router. As far as the customer was concerned, though, there were different parts of the design. They thought of this as, okay, if there's a global loopback where we protect, and there is a customer VRF loopback where we protect with different filter. At the end of the day, they're the same piece. You're protecting the router itself. But we actually had to come up with two different filters for that. I mean, in this case, just one filter because the core is not changing. So the new filter for IPv6 facing the customers had to actually include terms for OSPF v3, RIP-NG, VRRPv6. What was interesting is that what we noticed that the filters were we had to actually fix a lot of the stuff that was in the v4 filters because we thought it wasn't a very good filter. And then based on the new updated filter, we created a v6 filter. There were also RPF checks for IPv4 on other interfaces, and we did the same thing for IPv6, just turn it on for IPv6. Conceptually the same. Finally, we have the public network, which a lot of the talks you probably always heard is about the internet. And so, the goal was to turn it on as everywhere. I mean, the goal was to turn it on every router, every edge router, and for most part, we actually reached that goal. Again, we decided to stay as native as possible. So the BGP sessions run over IPv6 endpoints using TCP/v6 on the native network, and this is how we peer with the subscriber network, on the public network, and that's how we peer with the subscriber network. ISIS carries, again, both IPv4 and IPv6, so we have shared fate in the IGP side. And if we were, I mean, my recommendation would have been to use OSPF. I mean, if we were starting from OSPF v3, I would have had a separate IGP, because the scaling issues are not happening right now on the number of routes and the number of BGP sessions or number of routes in IGP. Most of the scaling problems that I've seen is happening on the subscriber side, as far as the number of subscribers, number of PPP sessions, number of DHCP leases, things like that, as well as hardware restrictions on certain things. So, I mean, if you think one day you might have a v6-centric network where v6 is the dominant protocol, I mean, having them separate is actually not a bad idea. So to do this on the public network, on the Juno side, the ISIS didn't have to do, we didn't have to do anything to ISIS, because by default it carries both IPv4 and IPv6. You actually have to turn it off for IPv6 if you don't want ISIS to carry IPv6. IBGP, again, we created new peer groups for IPv6 to keep things clean. We didn't want to mess anything up by accident on IPv4 that was already working. And for eBGP peerings, again, separate BGP sessions, and we try to keep things consistent, so always have new peer groups. So the filters in QoS very similar on the edge. There were actually classifiers that set the DSCP to reset this DSCP to set it to 0 for internet entering the network, and we actually had to have DSCP v6 equivalents of that function. And just want to note that there are filters, and the filters were actually used in every part of this project. For security, they were used for multi-field classifications. In Junos, use filters for, because a lot of this stuff was Junos-based, use multi-field classifiers through use of filters. And all this stuff had to be converted to IPv4. And when you have a complex filter with things like policers built into them, then that's when a lot of times when you see some hardware not supporting IPv6 the way it should. So as far as the security, the filters to protect the router itself is concerned, now we actually, for the public internet, we actually have to have new global IPv6 loopback filters. So we have to have equivalent terms for things like BGP and actually SSH is not correct, because we didn't change SSH to IPv6. So since we didn't take a lot of the network management functions to IPv6, the filter didn't necessarily have to change for those. On the edge, again, we had to change everything that we had to accommodate for IPv6. So what did we learn? So three slides on what were the lessons. So dual stack is not necessarily the solution people are, in the long term they believe in, right? There needs to be another step to help with the IPv4 address space exhaustion problem. And from what I've seen, almost everybody thinks that, even though nobody really likes it, that the carrier grade NAT or large scale NAT, CGN, is part of the puzzle somehow. Either by just, hopefully not, but either by just doing the double NAT or as a combination with another technique, either with 6RD or the one that our customer was interested in, DS Lite. So the key thing here is that there are other steps that need to be taken after this, and that's a new phase of this project, and the answers are not finalized. But the design had to keep that in mind. So as I mentioned, you have to have CGN, for example. If you think you're going to have CGN and if you're going to mess with your profiles on your subscriber side, you should think about how you're going to route those customers that you have to do an extra NAT on them. Okay, so that's the future. The hardest part, again, or the most time-consuming part, is figuring out what it is that we have to configure for IPv6. I mean, this was more than just turning on the routing protocols. So because we had to do, so parallel to this project, we actually had people working on the billing systems and provisioning and things like that. And so everything had to move hand in hand. And the most important part of this project is trying to figure out what are the pieces, because a lot of times people don't even know what are the pieces in IPv4. And I've seen, I mean, it's unfortunate, but that's really true. Or they have it and it's outdated. So once you figure out what are the pieces, then as I mentioned, you figure out what is worth moving to IPv6. And this process is not necessarily I'm not even saying that this is what everybody should do. This is the way I went about doing it. And what was worth to IPv6 and if it made sense. And this is where you actually had some sort of cost analysis involved, because a lot of times if you wanted to have certain service, it would have scaling consequences. And having scaling consequences mean you had to upgrade. And one question, for example, that had to be answered, and I had it somewhere, I didn't talk about it, is on a BRAS device, on a LAC device, which customers are you going to move to dual stack? Is this only going to be your new customers, or are you going to move all your existing customers? There's pros and cons to each. If you move everybody to dual stack, it makes the management of it easier because everybody is the same. Everybody has this basically the same configuration. But then the IPv4 and IPv6 scaling, you hit the ceiling at different points. So it does help you to have only the new customer go to V6 because you save on the scaling ceilings that you're given. So these are the kind of decisions that are technical, but then very much so involve cost analysis. And then finally, as far as that's on the scaling side, but then also there is like what I mentioned, like fixed IP customers that for IPv6 you cannot do it that way, or you really will have scaling issues very quickly. And for those, we actually came up with a different, really kludgy design because the customer wanted it. So we came up with a design that actually involved doing tunnels and into LNS and just having a cluster of LNS with a subset of the routing just for the IPv6 customers that want fixed IP. So the devil is in the implementation, and IPv6 scaling is what's going to hit you. I don't know what hardware everybody uses, but it's going to be different for different people. It could be, you can hit it at different places depending how you configure it. It could be the routes in control plane. It could be the routes in the data plane. Number of dual stack interfaces. Obviously, this is one of the things we definitely saw. For us, the IPv6 leases, number of releases that the LAC device can hold on at any given time, that was our first one. And as soon as you try to fix that, then you hit the other ones. And don't assume that features work equally. Like what I mentioned with filters, I mean, certain things that work with IPv4 don't necessarily work with V6. I mean, we were lucky enough that almost everything was officially supported, except that what means supported doesn't necessarily mean that it's supported on the hardware and software that you're running. And finally, you need to have an organizational commitment if you're going to make this as a big service and as an official service that all the organization is behind it. So this was something that this customer was going to make a big deal of and make, have the marketing team was ready to go on and announce it and things like that. So there's provisioning systems and billing systems and marketing and peering agreements. So you needed to have executive support of this on all levels. And we actually had this because at the beginning I was told that this was one of the biggest things on the CEO's radar. So that is very important. That's all I have. And if you have any questions, I'll be happy to answer.
Hi, Kathy Aronson, Cascadio. I'm not exactly sure how I want to ask this, but there's something comforting to management about running routing protocols ships in the night as opposed to just turning on a new feature in ISIS. I just wondered, like, how stable is the V6 edition and how easy is it to turn off? I use OSPF, so I...
So most of the problems of stability and bugs we ran into was not in the core. So as you move more towards the edge, we saw most of the problems. The dual stack ISIS has been very stable in the places that I have seen it. We did about 3 months of testing on this. After this was done. We didn't test OSPF in this project, but I do have another customer who is using OSPF for IPv4, and they're going to do ISIS for IPv6. So in that case, ISIS is just solely for IPv6. So I haven't done OSPF v3 in practice as far as running in a network, so I cannot give you data points on that, but ISIS has been quite stable.
And what are the main bugs at the edge that you see?
Are you just concerned with routing protocols, or are you talking about everything? We had problems with the way that we had a lot of problems with the DHCP leases. We had problems with the neighbor discovery process, the way the prefix was assigned through neighbor discovery. LNS, actually, we had issues where certain things were not tunneled for IPv6 from the LAC to the LNS. So on the subscriber side, probably was 80% of our issues. And that's probably because people have more expertise on the people have more expertise on the core side, and on the edge things were old. Things were, on the subscriber side, things were old. They were older code, and people were just neglecting the network more than they were with the core. And so I think a lot of it had to do with because we were running stuff that was way old.
We're going to have to stop here.
Okay. Thank you.